Welcome, everybody. We're really excited to be here with you on what is our first talk of reInvent. But we would like to do an audience selfie with you all, so if we can, really quick. Everybody say, yay!
Cheese! reInvent! Nice.
All right, now, can I just quickly get we're excited to be here, woohoo? On three. Ready? 1, 2, woohoo! All right, we'll take it. So I want to thank all of you for being here with us today. I don't know if this is your first talk, it might be your second, but we're kicking off an amazing AWS reInvent. You are here at the talk, which is Supercharge Your DevOps Practices with Generative AI. I am Julie Gunderson, manager of the Developer Insights team at AWS as part of the Developer Experience Organization. And I'm joined by Chris Williams, Senior Solutions Architect at AWS, and Chris Williams, who is the Manager of Developer Relations at HashiCorp. So we're going to have some fun, hopefully, and we'll know who is talking.
I wanted to go with handsome Chris and great personality Chris, but they wouldn't allow it.
It got awkward. Right. It was a little weird. We were going to call the talk Julie and the Chris Squareds, but again, we thought maybe you'd want to know what you were talking about going to hear today.
Would have helped.
Yeah. So about what you're going to hear today. So we're going to talk a little bit about what is DevOps, why DevOps, how do you measure your DevOps maturity, this new thing, generative AI, and how it applies to DevOps, how you accelerate software delivery, enhancing operations, and then we'll do a quick summary, and there will be an opportunity to ask questions. We have somebody in the back that will be passing the mic around for us, so if you want to think of those questions now, go for it. But let's talk a little bit about why DevOps. So I want you to imagine that your organization has said, okay, we're going to make and build the most complicated Lego ever, which it isn't Rivendell. I've definitely built more complicated ones than that. But how they're going to do it is they're going to have one team design all of the pieces. And then they're going to have another team actually build the Lego, but without any instructions. It sounds chaotic, but that's actually how software was made and delivered for years. Teams operated in silos, with the developers creating the code and tossing it over the wall to IT operations to run that code in delivery. And that caused 3 major problems. First, everything took forever. And then when something failed, it was almost impossible to find all the contributing factors because the folks that were operating the code weren't the ones that developed it. And then organizations spent millions of dollars trying to recover from failures. And actually, that's something that we're going to hear a little bit about later is mean time to recovery and recovering from failures. But I don't want to give Chris's part away, one of the Chris's. When we talk about what DevOps is, DevOps combines that traditional software development and IT operations, and it does that with culture, processes, and technology. So if we go back to this wall, imagine if we replace that wall with a circle, which I don't have the picture of the circle right now, so I'm sorry, but let's imagine the circle. First, we start with plan, then we go to code, then build, test, deploy, operate, and monitor. And it's this continuous cycle. And the goal is to increase delivery speed, improve code quality and reliability, and enhance collaboration, which increases efficiency, which gives us the ability to adapt to market changes. Now, when we look at the challenges that DevOps addresses, we've identified 5 main challenges. So first, we look at scale. With DevOps, we have tools and practices that help us seamlessly and repeatedly scale apps and services without interruptions. And now, organizations, you all were all expected to rapidly ship features and updates faster than ever before. And with DevOps and continuous integration and continuous deployment, we reduce time from committing our code to it being in production. And then reliability, which is very close to my heart. Organizations can't afford to be down anymore. When an organization is down, it hits the news, it hits the stock prices. People's lives can be impacted. You could get stranded at an airport for I don't know how many days, you know? But too soon. Sorry, downtime is not an option. But DevOps practices, they ensure that consistent performance and that rapid recovery from failures and continuous monitoring so that we can catch those issues before they affect your customers. And then, as I mentioned before, collaboration. So we had these siloed teams that were working towards different goals with different objectives. Now we collaborate and we break down those walls so that teams are working together with unified responsibility and unified goals. And then security, which actually should not be the last on this list. It probably should be the first on this list. Security isn't a checkbox at the end that's more of an afterthought. Now we have DevSecOps, right? Security is baked in through that entire DevOps life cycle because we're in a world where there's constant threat, and we need to always be thinking about security. But what I'm going to do now is I'm going to hand it over to HashiCorp, tall Chris Williams.
Which Chris Williams?
Tall Chris Williams, to talk about how we actually measure our DevOps maturity.
Thank you, ma'am. All right, hello everybody. Julie talked about the what, the why, and now we're going to go a little bit into the how. How do we measure successful DevOps mature environments today? The good folks at DevOps Research and Assessment, DORA for short, have created they've done all the heavy lifting for us. They've created 4 metrics that we can use to decide whether or not an organization is mature, scalable, and robust in their software delivery process. So the first metric, and we're going to go through these quickly. Some of you might have heard this already, but this is important when we're talking about our demos at the end of this because we're going to be leveraging generative AI to improve on these 4 metrics. The first one is lead time for changes. That is the time that it takes for you, once you've done a commit into your environment, how long it takes for that commit to get into production. That is a function over time, and more mature environments have a much shorter lead time for that. The second one is deployment frequency. That is, over that period of time, how frequently you can deploy. So those 2 metrics together are known as your throughput metrics. That is your velocity over time for affecting substantive change into your production environment starting from commit. The other side of that, just as important, is your change failure rate metric, and that is a percentage of, after you've made a commit into production, how many times, percentage-wise, that change fails. That is a signifier. Obviously, the lower the change, the more reliable and scalable your DevOps environments are. And then mean time to recovery. Mean time to recovery is the time that it takes for your monitoring, and this is an important piece, for your monitoring to catch that an anomaly has happened, and then for you to get to the point where you have rectified that in production. Whether that be a patch or a version rollback, those are your 2 stability metrics. So we've got your throughput metrics, velocity over time, and your stability metrics, which are a function of how well you're actually getting it into production and not falling over. So if you search for state of DevOps or search for DORA metrics, you will come to our friend Nathan's page, and you'll be able to see how your environment ranks up. There's actually a questionnaire that you can take, and it'll tell you how well your own company's environment is doing as compared to elite, high, medium, and low organizations. I would also be remiss, and Nathan would be very upset, if I didn't mention Goodhart's Law. When a measure becomes a target, it ceases to be a good measure. And now what that means is that if you laser focus on one of the things, like if you focus on change failure rate, your lead times and your deploy frequencies are going to unnaturally extend because what you want to do is you want to implement holistic changes across your environment, and then these numbers will naturally fall. Don't focus on KPIs and OKRs. I know that's a dirty word sometimes. Okay, so speaking of lead organizations, how do they do this? What are the things that the best of the best do? Automation. Automation, I'm not going to do the automation thing, but CI/CD, tools like Jenkins, GitLab, GitHub, all of these things help to automate, test, build, and deploy more frequently, and automated testing ensures that your code changes are validated more quickly. Infrastructure as code. Tools like, oh, I don't know, Terraform, things like that. They help to ensure consistency across your environment, allows you to do version control. All of your environments are structured so that dev, QA, test, prod, they all look the same, and they all can be versioned properly and appropriately. Testing and monitoring, Selenium, JUnit, Grafana, Prometheus, leveraging tools in your environment so that you can actually test and do change failure identification more proactively. This will naturally lower your MTTR. Version control and code review, again, making sure that your merge checks, your PRs and your merge checks are being validated appropriately in an automated fashion, as well as having human eyeballs looking at them. Having in feedback loops, having very good, cohesive, consistent monitoring, unit testing all throughout your entire chain. And then finally, self-healing systems. Things that are going to leverage your monitoring and then use auto-scaling groups, service restarts, things like that to make sure that your environments are up and running and stable. So, back to Julie. Let's talk about more of the what.
Oh, thank you, Terraform, Chris. So, when we talk about generative AI for DevOps, automation continues to evolve. And generative AI is that next transformative force because it enhances our capability for intelligent decision-making and process optimization. So when we look at that, there's kind of 4 key areas here. So we have enhanced problem solving. With these enhanced problem solving capabilities, they create creative solutions to complex challenges. Unlike the traditional automation tools, which generally are rule-based or repetitive tasks, generative AI can analyze situations and it can actually propose innovative solutions to unprecedented problems that we may not have seen. Generative AI also increases operational efficiency by automating the sophisticated cognitive tasks. In other words, it reduces that cognitive load for us humans in the room. Although we are still needed, it is a significant advancement over what we've had up till now. Generative AI also has adaptive learning capabilities. So it ensures continuous improvement through real-time feedback and data analytics, and it's a self-improving mechanism that creates increasingly sophisticated automation over time. And then scalability, which you'll hear me talk about a little bit more. With generative AI, it enables organizations to expand that automation with unprecedented flexibility by addressing these evolving technology challenges that we're facing today. And so when we look at the generative AI stack, generative AI has now been democratized. And that's a fundamental shift in how we do software delivery. And it's created this multi-layered ecosystem that enables that broader access to all of those AI capabilities. At the foundation, we have the infrastructure layer. So listen, if you're building your own models, then you need to have the tools to build those LLMs and those foundational models and the data scientists. Where developers really love is this middle layer here, right? It serves you who are looking to integrate generative AI functionality without having to manage that complex infrastructure. So this abstraction layer, it provides pre-configured generative AI services and APIs, which enables the developers, you all, to focus on app development versus the infrastructure. So we talk about this in terms of Amazon Bedrock. This is where we come in. Bedrock provides that catalog of models from the leading providers like Anthropic or AI21 Labs, Meta, Cohere, Amazon's own Titan model, all of those. And through an API, you can infer your model of choice and directly embed that into your application. Then we get to the top of the stack here. And here's the applications that you use that are powered by generative AI, leveraging those foundation models. And generative AI has the power over time to transform virtually every customer experience that you can think of. So it can pore through the nooks and crannies of your system to find data that you didn't even know existed, and then actually help you put that to optimal use. And it can generate insights that can save you hours of manual work. You're going to hear a lot about Amazon Q Developer this week. And look, it can do some amazing things. It can help you understand your code. Heck, it can write your READMEs for you. It can generate unit tests. It can scan your code for security vulnerabilities. Ultimately, this helps developers spend time doing the things that you actually like to do, and it reduces the barrier to entry for AI adoption. So it enables customization based on your specific organizational needs, your team needs. It maintains flexibility in deployment options, accelerates those development cycles, and optimizes resource utilization. But you don't have to take my word for it. I will bring up AWS Chris Williams, and he'll walk us through a demo of this.
Thanks, Julie. OK, so we've come to an understanding of what DevOps is, how we measure it, and we even looked at some generative AI tools. But I think if you're really going to understand the benefits, you need to experience it. And so that's what we're going to do now. We're going to actually jump into a demo scenario where all of you are DevOps engineers who have just joined a company called AnyCompany. Now, AnyCompany creates the innovative and captivating puzzle games, but has some challenges in their software development lifecycle. Now, here is a sneak peek at a game that we've actually been prototyping recently and decided it should be immediately available to production. The aim is that players are going to guess what type of animal the system has thought of. Now, the idea is you get to ask a number of questions to be able to try and understand maybe the characteristics. For example, are you a pet? Or do you have 4 legs? When you ask these questions, it's going to just keep a log on the right-hand side, so you can actually refresh on this a little bit later. Now, once you think you know enough about it, you try and make a guess. Here, we're going to guess cat. But unfortunately, that was incorrect. But you can ask a number of other questions. And then once you think you know enough, again, have another guess. This time we say, do you woof? Then we guess whether or not it's actually a dog. Cool. So you're probably asking, where do I come in? Now, as I mentioned, we have challenges around our software development lifecycle. But the biggest hurdles right now that we're going to focus on is actually around accelerating our software delivery. We'll come to operations a little bit later in the session. Now, organizations have many challenges that actually impact this, that cause hurdles, both kind of cultural as well as technical. We have challenges around things like technical debt, actually delays in our software development lifecycle, but even actually lack of automation, which means we don't have confidence in being able to deliver at pace. But in addition, we've also recently worked out that we have problems around scoping our challenges. Maybe they're not giving enough information. Giving the wrong priorities and actually causing distraction so that our developers aren't working on the right tasks. Now, we've been able to summarize this as 3 tasks. This is what you're going to be working on first this morning. The first of these is around accelerating our engineering productivity. Now, for this, we're going to jump into the IDE and look over the shoulders as a developer is able to use one of the tools that we just talked about to actually accelerate their productivity. OK, so here in the IDE, we have the code base for the game that we just looked at. It contains everything that's needed, everything from our infrastructure, our back end, our front end, basically everything that's needed for that code to run. Now, if you're new to a project, it can be hard to understand exactly how you'd put this together or where you would need to go and make changes.
So, Chris, can you increase the font size a bit?
This is a video. It's not possible to increase, sorry. Right, so, OK, so what we can actually do is use Amazon Q Developer to actually ask questions. For example, I can ask a question around where a particular piece of logic is. Let's say we want to add a new topic for one of those animals. We can actually say, hey, can you tell me where the topic logic is defined within this application? Now, once we actually submit that, Q Developer is going to begin to actually explore within our workspace, within our code base, and actually determine where the answer actually is. It's then going to write up an answer, just like you were asking a colleague, which is actually going to help direct us on our way. Now, we can see here, we actually have quite a lot of text, which is breaking down a bit of a summary. We have an actual code snippet there. And what this is going to do is actually give us a direction on where we probably need to step into first to solve that problem. Now, it's also included the actual Lambda function here that we need to go ahead and make the changes to. And so now that we have that, we can actually go ahead and we can open that file within our Explorer. OK, so opening up that file is a Python-backed Lambda function. And if we just scroll down to the bottom, what we can actually see is actually the code snippet that was just proposed to us. Now, before we actually dive in and start making a change there, you probably noticed there's quite a lot going on in this file. And so rather than actually just diving in and making the change, it'd be good to understand what's happening. So opening up Q again, we can just ask the question, this time just saying, can you explain to me what's happening here? And it's just going to summarize what is actually happening in this file. Now, once you'll see it actually starting to generate the answer, you'll notice it actually breaks it down quite logically. It understands going from top to bottom, here's what the workflow is, here's the potential different divergences in logic, for example, when particular API actions are called. And at the bottom, even calls out the key points, so we actually are able to rapidly understand what's happening without having to read the full details there. So this is really useful. I think now that we understand, we can go ahead and make that change. We're just going to scroll down to the bottom. New animal, we're going to add pandas. Pandas are awesome. So we're going to add that in there. Now that we've added that, we're just going to make another change. I actually realized that as you were going through the file, there's quite a lot of logic that looks like it's repeated. QDeveloper can help us here too. Now, if we was to actually look through, what we can see is the return types here are actually being repeated throughout this. Again, you can see it there. This probably needs to be more modular or component-based. We don't want to have this all in one function. So what we're going to do is actually select all of our code, just like this. We right-click, we say Amazon Q, refactor. And what that's going to do is actually put it into our chat and begin to look through the code and understand what is the logical breakpoints that we can move that into. Now we can see it's actually going through, it's generating the code. It's not going to replace the logic. It's actually just going to simply work out what is a more efficient way of actually having this, so that actually not just for the now, but actually for the future, it'll also make it a bit more readable, make it easier for developers to add further changes there. So that's our code still generating. What it's going to do is, once that code's generated, just provide us with a summary. Here's the changes I made. Here's why I made them. And if we're happy, once we review, we can just copy the code and simply paste it into our IDE. And what we'll see from that is actually we've managed to save quite a few lines there. Now, the logic's not replaced, but it's a lot cleaner, a lot easier to actually read and comprehend. So that is pretty awesome. Now, we're going to do one more thing with QDeveloper for this task, something that people try to put off as much as they can. Has anyone got any guesses?
It's unit testing.
So it is. It's unit testing. Now, thank you. Now, just as before, we can actually just write a question in the chat. This time, can you create me some unit tests for this code? And again, it's just going to, once we submit that, look through the actual code we have open within our IDE, within that open file, and actually understand what is the best way to write unit tests, actually to write Python-based unit tests. Now, that's going to include things such as making sure that we're mocking AWS service APIs. It's going to make sure that we are accounting for the parallel workflows, even edge cases that might exist, making sure that our unit tests are properly evaluating for that. Now, it's actually generating quite a comprehensive suite of unit tests, and then actually telling us at the end, here is the unit test I've created, here's the reason why, which ultimately has helped us to actually accelerate our time to improve our code coverage. Now, just reflecting on what we've actually done for this one task alone, within a few moments, we've been able to understand the code base, we've been able to make changes, clean up the code, and add unit tests. In my opinion, in just a few moments, we've been able to make some pretty huge leaps forward, especially considering we'd never even touched this before. OK, so let's mark that task as done. Now, our next task is actually around software development lifecycle bottlenecks. It seems that actually, for some parts, it seems to be slow and inefficient. Now, to do this, we're going to jump back into our IDE. We've actually got a CSV that we've exported from our issue tracker that basically just keeps a log of actually what's happening as tasks move around. But there's actually a lot of data in here. That could take a little bit of time to analyze. Now, fortunately, we can actually use QDeveloper again. This time, I'm going to ask questions like, what insights can you draw from this? And it's going to understand the patterns it finds within the CSV. Now, this is all possible because behind the scenes, QDeveloper is actually powered by Amazon Bedrock, which has large language models. They're really good at comprehending and being able to do some of this analysis quite rapidly. Now, we see here we have our results. It's actually called up 11 key points. This is quite a lot of things that we can action on, at least initially. Let's just scroll up, and we'll take a look at a couple of the points here that maybe we can action within the next session, or within this session. So firstly, we can see task complexity. What it's actually indicating here is that for some tasks, there's a bit of a backwards and forward stance. Right? So this is normally where tasks haven't necessarily got enough information, and so developers are passing back so they can get further clarification. That's not great. So let's just scroll up, see if there's anything else that maybe we can act on quite quickly. We see here, actually, when it comes to time allocation, features are taking much longer than a bug or a small enhancement. Now, we would expect features to take long, but for a single task, this probably indicates that actually we have too much going on here. So what we'd want to do is probably break these into subtasks so that developers can work on these smaller chunks at a time. OK. So you run your analysis. We can mark that task as done. We'll add that onto the ticket. Now, for our next task, we're going to have a look at reducing developer distractions. I think we can actually probably use what we just learned during the analysis to actually focus on those couple of key things first. So this time, rather than being in the IDE, you have implemented something behind the scenes that is actually going to perform some of this automation for us. We're in our Kanban board for the What Am I game. And what we're going to do first is actually validate our task descriptions. So when you add a new task, for example here, we want to add one for additional categories beyond animals, what's going to actually happen is it's going to validate the actual description that we put in. Now, once we've created, we're just going to have to select what the ticket type is. We're going to select feature because we're going to do some additional automation for features shortly. So we select the type as feature, and then what we're going to do in the description is we're just going to put a very basic description. We're going to purposefully try and trigger a workflow that is actually going to say that this ticket does not have enough information. So the ticket is created. Let's just open it up, and we can actually see what the automation actually does for us here. Now, within a few seconds, what we're actually going to see is that the comment is actually going to get a DevOps bot that we have built is going to actually add a lot of insights. Behind the scenes, we've actually given it a set of instructions and said this is what tickets should have. For example, testing criteria, acceptance criteria. In addition, it's reassigned it to the requester so that it doesn't immediately go to a developer to pick up and push back here. Now, what actually did we do to do this? Within our third-party issue tracker, in this case Jira, what we've actually done is we've triggered an Amazon SNS topic. The SNS topic is actually subscribed to an AWS Lambda function, is responsible for starting our orchestration workflow. That workflow is actually within an AWS step function state machine, and for its first task contains this evaluate task description Lambda function. Now, most of the magic is actually happening in Amazon Bedrock. What we've done is taken a description that's passed through and actually then given a set of instructions for a prompt to Amazon Bedrock. We're going to call out, for example, make sure it contains these sections very clearly within it, but also going to give it a couple of examples of what a really good ticket is so it actually understands what it should look for in terms of quality. Now, in the event that actually it doesn't meet the bar, it's going to pass a JSON response, which is going to simply say it's failed, but here is a comment to pass back. That's going to then update back via an API to Jira, so it doesn't actually automatically go into the developer queue, but without having to have any kind of human-in-the-loop experience here to be able to do that validation. So now that we've looked at our description, what we're actually going to do is update it with some clearer instructions, but we can go a little bit further here. Now, in the previous task, the analysis, we found that actually those bigger tasks, those features, are taking a while to deliver. Now, the way that you would normally do this is actually by creating subtasks. So that's what we're going to do next. Now, once our description is passed, what we'll see is a little icon is going to appear there, which indicates some subtasks have been created. Once we click on it, what we're actually seeing is it's actually created a number of subtasks, titles, descriptions, quite clearly, that actually overall achieve the objective that is set out in their description. So, going back to our diagram, all we've done is actually added a second stage here. We've added a Lambda function that is used to actually define our subtasks. What this is doing is actually just passing in that description and saying, can you create this into components that are going to take less than a day for the average developer to do? After that, it's then going to, again, update back via the API so that actually we've got that in there for developers to start picking up those tickets. Now, we mark that task as done. Just refreshing on where we've gone. In a short period of time, we've been able to actually to make some great strides in our software delivery cycles. We've been able to introduce tools like QDeveloper to accelerate the productivity. We've found where our bottlenecks are within our life cycle. And finally, we've been able to add some automation within our issue tracker to actually alleviate the needs of some of those tasks that are actually causing those delays. Now, you're not done. Next, we're going to hand over to Chris Williams, who is now going to take us through improving our operations.
Thanks, Chris Williams. All right, so that was Dev Chris Williams taking care of the, going back to our DORA metrics, we're talking about the throughput metrics. Throughput was what we were just addressing. Now we're going to look on the other side of that, and we're going to look at more of our stability metrics. So the challenges that we face from a stability metrics perspective are things that we've all seen. Code quality not being taken seriously when you're doing reviews. Too many looks good to me's, not enough concise, vetted out business. Actually, I apologize to Bruno. I've actually done that to him just very recently. Sorry for the LGTM. Not doing thorough code reviews, validating both against the business priorities and the technical priorities that were stated in the JIRA ticket. Lack of observability and monitoring, of course. As you're implementing new features, you want to make sure that you're monitoring them sufficiently. Complex troubleshooting and poor incident response. Not going through the due diligence of creating an incident report, making sure that there's a postmortem, and all of the things that when the rubber hits the road, people get busy, and things like that are the first things that fall to the wayside. So how can generative AI supercharge these aspects? I'm glad you asked. First, we're going to give us another 3 jobs on our board: improve code quality, reviews, enhance monitoring, and streamline incident response. Let's start with improve code quality and reviews. So we're going to take the categories that Chris just implemented. We are going to do a PR. We're going to merge it. We're going to create the pull request. And for this first iteration, we are going to be using CodeGuru to run through something that you've probably already seen before, getting recommendations back from CodeGuru without using generative AI. We're going to show you good, and then we're going to show you better. So CodeGuru goes through its analysis, the PR is raised, begins to analyze our code, and then it comes back with some responses, make sure your backups are good, security, performance and considerations, all the regular stuff. This is good. And let's walk through a little bit of the architecture of how that happens, and then we're going to enhance it again. As you can see, it's giving us all the recommendations stated and some code change recommendations. So we've got our get user. The PR is raised. This triggers the CodeGuru to do via a webhook. CodeGuru goes back to the third-party repo. It then copies it down to an S3 bucket. CodeGuru does the review. It scans it, and then it responds back and gives us the information that you just saw on the board. But now let's use generative AI to improve this process. We now have this thing called the DevOps bot. I'm going to show you how this works. This is really cool. So this feedback was generated by the DevOps bot. And it is actually going through and doing a full-fledged review. It is taking a look at the changes. It is pulling information from the JIRA ticket. It's consolidating all of that using some very clever prompt engineering that Chris Williams created. I do have to say, I really, really dislike coming on after a person with a British accent, because it's the audio equivalent of going from a filet mignon to like a cheeseburger. It's very disconcerting to my ear. Thank you. All right. So this is going through, and it's reviewing it against the organization's best practices. It's seeing that we have, in fact, neglected to get monitoring and logging as we specified previously. It is also taking a look at the original JIRA ticket, confirming that it does map exactly to what we wanted it to do, so this ties off and makes the business happier. And finally, it actually gives us a proactive and itemized list for the developer to tackle to make sure that everything is being taken care of. So this is really cool. How did we do it? So we've done it by raising another webhook into Amazon API Gateway. This then calls a Lambda, which then feeds the external requirements, both the PR and the JIRA ticket information, into Amazon Bedrock, where we have basically told it to assume the role of a senior review developer. Here is the information that is salient to our organization. These are the things that we care about. These are previous examples of code. Make sure that there's no bad code smells. Make sure that we are doing logging and monitoring, which we didn't, and we're going to catch that in the next one. And finally, the pull request is fed back to the developer to take care of. So that's super awesome. We have one off of the board now. Let's take the incident that we just called up and deal with some incident monitoring. The first thing that we're going to do is we're going to jump into Amazon Q once again. We've got our main TF on the board, and once again, we are going to be using it with just regular natural language. We're going to talk to Amazon Q. We're going to ask it, hey, we forgot to do monitoring and logging. What are the best metrics to put into this file, taking into consideration our business considerations? So we've put up that we need 4 nines of consideration or 4 nines of response time, 4 nines of uptime, and a 2-second response time. So now that we've done that, we hit return. It gives us all of the information that we need back. It pains me to say it, you don't have to go to the docs. I dearly love the docs, but and obviously you want to make sure that you vet all of this. These are things that you test. Do not trust AI out of the gate. It does save you the search online though, but you obviously want to make sure that you do your due diligence. So now we're going to ask it again using natural language, help me add it to this file. Notice I did not say, help me add it to this Terraform file. It knows that it is in fact a Terraform file. It then starts giving us the recommendations and generated suggestions. And then once we've reviewed the information, again, testing it, we don't just copy and paste and stick it into prod. We make sure that it's validated, and we let it rip. And the let it rip part is going to be in the next bit, which is actually so, okay, sorry, hold on 1 second. We've finished streamlining, we've enhanced the monitoring. We're now going to work on streamlining the incident response. This one is the one that I'm particularly excited about because I have spent millennia working on after action reports and all of the things that go bump in the night. So this one was really awesome. So let's deal with this. We have our war room. Something has gone bump in the night. We have chatbot call up a flag. We have an event. We go into the war room. We acknowledge the alarm. Again, we're using natural language in the Slack channel to make sure that we're taking a look at it, and then we go and jump in the console. Go over to the Lambda, hit test, run the environment, and we do find out that yes, in fact, there is an issue. We diagnose with Amazon Q, and we find out that it runs the analysis, and we find out that it is an IAM access issue, as it almost always is. And so now we ask you to help us resolve. So we click on Help Us Resolve. It then goes through, it picks up the resolution. It gives us a very granular, it identifies the name of the role that needs to be affected. It gives us a very granular policy to add to the role. And then we take care of that. We add it in there. And we go back to the environment, and the chatbot then eventually comes back with an all clear. So now what we want to do is we want to click on Create Report. And what Create Report is going to do is this is going to capture a history of the request. It's going to trigger a Lambda function on the back end, and it'll grab all of the events surrounding the incident, and we're going to format it into a clearly readable format. And so let's take a look, after it finishes, what happens behind the scenes. So the incident has finished. We've clicked generate report. This triggers a Lambda, which is then going to trigger a step function. And inside of the step function, what we're going to be doing is we're going to scrape all of the information from the CloudTrail log from the start of the incident to the end of the incident. It is then going to go in and do the exact same thing in the chat log, capturing all of the back and forth between you and everybody that is having heated conversations in the chat, because we always do. And then it is going to be feeding all of that information into Amazon Bedrock. Again, we are using prompt engineering to say, assume the role of an incident manager, take the information that you grabbed from the beginning to the end of this, create your, what happened, what were the remediation steps, what were the things responsible, what were the lessons learned, and how are we going to fix this in the future. So this is then triggers off another Lambda, which then uploads the report into an Amazon S3 bucket. So now that we've done all of that, there's actually a little bit more that we can do that makes this go significantly faster when we're trying to deal with MTTRs. Now, we've triggered the incident again, and the incident has happened a second time. Now we have the button Search Incidents. We are now going to leverage generative AI to create a dynamic runbook for us that is going to give us the report that we need for the next person dealing with this issue down the line to take care of. This would have been a huge time saver back in the day. So this is the reason why I was so excited about this. So you can see here that it is giving you a detailed report and exactly what the next person needs to do. So how did we enhance this? Once the incident was dropped into the S3 bucket, it then triggers an S3 event notification Lambda, which causes Amazon Bedrock with a knowledge database to vectorize the report. The vectorized report is then fed into OpenSearch service so that the next time an event like this happens, we have that button that causes the search incident button to be available to us, and that Lambda then uses Amazon Bedrock to create the dynamic runbook with the information fed into it from all of the previous incidents. This right here, when I saw this, I was like, this is a potential game changer when it comes to turning MTTRs around in a standard DevOps environment. So now we have streamlined our incident responses. We've lowered all of our DORA metrics, and the bosses are happy. Julie, let me hand it back to you.
Thank you, bearded Chris.
You're very well. Wait a minute, he's bearded too.
Tall Chris. So there's a few resources that we have for you today. First, you can play with Amazon Q Developer with this first QR code. You can get hands-on experience with Amazon Bedrock with this second QR code. But wait, here is our woohoo moment. This third QR code, do more with Builder ID. Do you see this amazing jacket that I'm wearing up here today? With these little tags, one has my name on it, Jules. If you go here and sign up with your AWS Builder ID or for a Builder ID and create a profile, you will be one of the lucky few at AWS reInvent who on Wednesday morning can go to Swag Pickup and get your very own bomber jacket. So that's our woohoo. Can I get a woohoo on that? Woohoo! So definitely go over there and do that. And actually, that'll take you to community.aws, which is a site that is actually run by the Developer Experience Developer Relations team. And I'm going to volunteer AWS Chris to go ahead and write up a blog post with these demos. So for those of you that couldn't see, they will be on there. Can you agree to that? Yeah, what is he going to do, say no? No. And also, thank you for putting up with our smaller code. We did not say our prayers to the demo gods, so definitely did go with the recorded video today. With that said, I would like to introduce Jason Yee from Datadog, who will be monitoring the room for questions and handing that microphone around. Oh, before I do that, you can actually find us on socials. I'm on X at Julie_Gund, Julie Gunderson on LinkedIn, and I'm on Blue Sky at Just Jules. AWS Chris Williams is only on LinkedIn, and you can find him at the DevOps guy, and HashiCorp Chris Williams is on Blue Sky at Mistwire. He's also on X at Mistwire, and he's Chris Williams on LinkedIn. Well, thank you everyone for being here. Thank you to Jason Yee for being our mic runner, and I hope you have a great reInvent. Thank you.